finding the exact value, so exact value means radicals, no decimals, for each of these things. So if I said the sine of negative 15 degrees, how would I rewrite negative 15?
30 degrees and 45 degrees.
Mm-hmm. If you didn't like dealing with the negative, you could have always added 360, but since we can add or subtract, it's just as easy to just subtract those. So now I have the sine of something minus something, so that's the sine difference formula. So we do sine of the first, cosine of the second, minus cosine of the first, sine of the second. Again, we're not treating that second one as a negative 45. The minus is what told me which formula to use. So, sine of 30, 1/2. Cosine of 45, minus the cosine of 30, radical 3/2, times the sine of 45, which is radical 2/2. So if we multiply, we get radical 2/4 minus radical 6/4. And we talked yesterday, you can leave it like that, or you can write it as the square root of 2 minus the square root of 6 all over 4. Is that okay with everyone? So sine is very similar to the cosine. The tangent formula is a little different, but this process is the same. If I gave you something in radians, what did we do? So we do that by multiplying by 180 degrees over pi. Those pi's cancel. 13 times 180 divided by 12. Two things that add or subtract to 195. Okay. So now we have the tangent of A plus B formula. So that says tangent of A plus tangent of B over 1 minus, bless you, tangent of A, tangent of B. (150), since that's not in the first quadrant, we need to do quadrant reference angle. What quadrant is 150? Okay, reference angle 180 minus 150 is 30 degrees. So in second quadrant, tangent is negative. Tangent of 30, radical. Plus, what is the tangent of 45 degrees? Over 1 minus tangent of 150, which we already said was negative radical 3/3, times 1. Okay. So this one is definitely uglier because we have a fraction and a fraction, and we know we can't leave it that way. An easy way to eliminate that is to use a strategy that we use in our proofs, where you can multiply the top and the bottom by the same thing. So I might multiply everything by 3 on top and bottom. So then that would be a negative radical 3 plus 3 over 3 plus radical 3. technically, should we leave a radical in the denominator? No. So here's what I want to mention. On these problems, I am more concerned with making sure you know how to use the formulas. So I actually will allow you to leave your answer like this on these and only these problems, okay? I do expect you to get the fraction out by multiplying by the 3, but if you leave this radical in the denominator, I will take that. If you wanted to get the radical off the bottom, what would you have to do?
So that's 3 less radical 3.
You have to multiply by the conjugate. So I want to show you how that works, but I do not require that on these. So if you FOIL, we get negative 3 radical 3. Negative radical 3 times negative radical 3 is positive 3. Plus 9 minus 3 radical 3. On the bottom we get 9. Outside and inside cancel. Minus 3. So if you add like terms, we have 12 minus 6 radical 3 over 6. And that turns into 2 minus radical 3. So I just want you to recognize on these, there are several different equivalent answers. And actually, depending on your reference angles that you pick to begin with, you may get something with a radical in the bottom that still looks different than this fraction. And the way to check if it's equivalent, if you're trying to compare with your neighbor and see if you got the right answer, if you plug this or this in the calculator, they should have the same decimal equivalent. So I'm giving you a little bit leniency there. Know that if you went all the way and got the radical off the bottom, then all of our answers would look the same. Okay? Any questions on that? Let's see. What does that one look like? Yeah, that's like the tangent of A minus B formula. So my A is the 100, my B is the 70. 100 minus 70 is 30, and what's the tangent of 30? So these problems hopefully seem pretty familiar after yesterday. Do we need to do more of those? Let's do. I'm not going to do all of these, but we'll do a couple. So simplifying these things that have theta in them. So if I said the sine of 120 degrees plus theta, I told you to simplify that as much as possible. So this is the sine of A plus B. So if you look at your formula, sine of the first, cosine of the second, plus cosine of the first, sine of the second. 120, what quadrant is that? Reference angle. In the second quadrant, remember all students take calculus, sine is positive. Sine of 60 I don't know the cosine of theta. 120 in quadrant 2, cosine is negative. Cosine of 60? Anything else I can do from here? That's as simplified as it goes. Because we don't have any like terms. So you just simplify whatever you can. Let's do this is the tangent of A plus B. So look at your formula sheet, that's tangent of A plus tangent of B over 1 minus tangent of A tangent of B. I don't know tangent of theta. What would we do about this tangent of 3 pi? Okay, you can change it into degrees if you're more comfortable there, or you can recognize it's bigger than all the way around the circle, which is 2 pi. So 3 pi minus 2 pi is pi, so we're right here. Tangent is y over x, so 0 over -1 is y over x.
What is? I can't read.
So that just gives me tangent theta over 1 over tangent of theta. Are those okay? So we've kind of practiced using the formula and simplifying as much as we can. I would like to do a proof with them and make sure we're okay, and then you guys can get your math. So which side should we box in? Yeah. Anytime you have an angle with things added or subtracted, you want to work with that side because we have formulas to break those apart. So we have to do both of these. Tangent of pi over 4 plus t. So that's the tangent sum formula, tangent of a plus b. So that's tangent of A plus tangent of B over 1 minus tangent of A tangent of B. Then this one, we would have to do the tangent of A minus B. So tangent of A minus tangent of B over 1 plus tangent of A tangent of B. Tangent of pi over 4, that's like tangent of 45 degrees. So this would be 1 times tangent t, which is just tangent of t. Over here, tangent of pi over 4 is still 1 minus tangent t over 1 plus 1 times tangent t. Okay, we've had lots of questions like this. What do you do at this point? We have to get that common denominator. So the first denominator has 1 minus, so it needs the 1 plus. Whatever you do on the bottom, you have to do on top. This one has 1 plus on the bottom, so it needs 1 minus on top. Alright, so now if we start boiling, plus tangent t is 2 tangent t. Tangent times tangent is tangent squared. What do we get on the bottom?
1 times tangent squared.
Mhm. So this one, if we FOIL, we have 1 minus tangent t and minus tangent t plus tangent squared t over 1 minus tangent squared t. So now my denominators match, so we can make one big fraction. 1 plus 1 is 2. 2 tangent t and negative 2 tangent t cancel. Tangent squared plus tangent squared is 2. Tangent squared t. What do we do at this point? Well, yeah, if we, let's compare to what we need. We have the bottom. The top we need a 2, which we have 2 of them right now, and I need a single trig function.
You take the 2 out and do 2 times 2. 1 plus 2 is 1, 2.
What is 1 plus tangent squared t?
2 tangent squared.
Questions there? So I want to give you guys time to work and maybe get this done so you don't have to worry about it over the weekend. So your assignment 2 through 34, every other even. So it's like 2, 6, 10. Seems like some of us still get off on those.